Hello students, welcome to the class. So, in our series of crash course, today we will study organic compounds containing nitrogen. So, this will be our day 34 of our crash course. This is our disclaimer. First, we will talk about the chapter analysis. So, likely we are seeing one question every year from this chapter in your JEE paper, and there is 2.9% weightage regarding the organic compound containing nitrogen chapter. So it is also named as amines in your NCERT textbooks, right? What are the important topics from where questions are asked generally? So you would mainly see questions from the preparation and the chemical reaction. You can see in 2024, 2022 and 2021, and in the subsequent year 2017, there are questions always from this preparation and chemical reaction, and these are the only two important things. Specifically, an important part of this amines chapter is your diazonium salts. You know about diazonium salt. We have talked about this diazonium salt in your halogen chapter as well. Is my voice coming? Is it clear right now? Hello? Is it clear right now? Okay. So, if I say what are the important topics, so the first of all you have this diazonium salt, then you have your basic character. Okay, often we have seen a question from this amines chapter regarding its basic character, and next is your Hofmann degradation reaction and your Hinsberg test. So these are some important chemical reactions of your amines chapter. Then there are some questions from preparations as well. So we will cover each of them today. Let us start our class. What are the topics that we are going to see? So first we will just see a basic introduction of amines. How does amines look like and what is the structure of amine? Then we will move on to the preparation. After that we will see the physical properties. So these are the topics that we are going to cover today. Now starting from the introduction part. If I talk about amine, it is basically a derivative of ammonia. Why are we calling it as a derivative of ammonia? Because here we are removing one hydrogen atom and introducing alkyl group. Now you can remove more than one hydrogen atom, and depending on that we will get primary, secondary and tertiary amine. And the groups with which your hydrogen atom is replaced is your alkyl or aryl groups. Means it can be a benzene, it can be ethyl group or methyl and so on. Now this primary, secondary and tertiary group you are seeing, they are basically three different functional groups. So this is very important to remember. If you take the case of your alcohol, then primary, secondary and tertiary alcohol, all of them represent the same functional group. But primary, secondary and tertiary amines are three different functional groups. It's very simple to get them. If you remove one hydrogen atom and replace it with R, then you will get a primary amine. If you remove two hydrogen atom and replace it with R dash and R, here two alkyl groups are here. Then we have a nitrogen which is containing three alkyl groups. So these are the three types of organic compound containing nitrogen or amines, and these three are three different functional groups. Now moving on to the next thing, which is geometry and shape. Now what is geometry and shape? You must always remember the difference between the two. When we talk about shape, shape does not include your lone pair at all. It only talk about the molecular structure and excludes the electrons or the lone pairs. But if you are talking about geometry, then in that we include both the lone pair and the bonded atoms to determine the complete thing. If I talk about nitrogen, then in amine, your nitrogen is sp3 hybridized. You know what is sp3 hybridized? When one s orbital and 3p orbital are combined together, they just intermix to form 4 degenerate orbitals, and they are of same energy and same shape. Next, whenever you get this 4 sp3 hybridized orbital, they will overlap with the s orbital of hydrogen or with the sp3 orbital of carbon, depending upon the composition of your amines, to form your corresponding amines. Then, apart from this 3 bonded pair, we have a lone pair. You know it very well that the 4th hybridized orbital of nitrogen has an unshared pair of electron, and this unshared pair of electron is responsible for its basic character. If I talk about the Lewis basicity, according to the definition of base, you know that a substance which can donate a pair of electron comes under the category of Lewis base, right? And your nitrogen has one lone pair, so it is considered as one of the Lewis base. If I just try to move on to now geometry, so it is tetrahedral because it will include 3 of the bond pair and 1 of the lone pair, and in this case your steric number would be 4. You can easily calculate it if you want. There is a formula in the Whisper theory to calculate the same. You will get it as 4. So here is the shape. Now the example that you are seeing is an example of tertiary amine. Why? Because all of the 3 hydrogens are replaced by 3 methyl groups. What about the shape? While we are considering the shape, we do not consider this lone pair. So this 3 methyl groups and your nitrogen makes up a pyramidal. Right? You can clearly see here a pyramid shape is formed here. Therefore, we call it as a pyramidal shape. Next, what about the geometry? So geometry will be tetrahedral, because in geometry we will include the lone pair as well. So this is something which is important to remember about the shape and geometry, and also about the Lewis character, means why it is basic in nature. So basically this lone pair that you are seeing on the nitrogen, they can be donated and hence it can act as a base. Now moving on to the nomenclature part. If I try to define the nomenclature in common terms, then it is simply defined as alkyl amine. We will just put the name of your alkyl chain, it can be methyl, ethyl, and then we will write amine against it. So this is the common system of nomenclature. Then if we talk about the IUPAC system, then amines are named as alkanamines. Rather than writing alkyl, we write it as alkanamine. We remove this E at the last. So if you are taking ethane, you will remove the E of your ethane and write it as ethanamine. Or if I am taking butane, then it will be butanamine. So in this way, you can name your corresponding amines. Now here we have an example. Suppose we are taking amine that is present on the second carbon, then it will be named as propane 2-amine. Similarly, here NH2 is attached to a benzene group, so we will call it as benzenamine. Okay. What about the common name for both of them? It's very simple. So this will be isopropylamine. Okay, because it attached from the middle carbon, so we'll write it as isopropylamine. What about this? So it will be phenylamine. We will not name it as benzene, we will name it as phenyl. Got it? Moving on to the preparation now. So we have talked about its structure and the nomenclature. Now we'll learn about the synthesis, how you will synthesize an amine. So various methods are present and they are specific for 1 degree, 2 degree and 3 degree amine. There are some methods that would give you a mixture of all, but we will talk about the specific reactions. First of all, your alkyl nitriles, nitroalkanes and oximes of aldehyde and ketone and the primary amides, all of them can be reduced to give you the primary amine. You know what is reduction? It is simply the removal of oxygen. Suppose this is your nitrobenzene. You can reduce this thing in the presence of H2 and PD to give the corresponding aniline, and this is used commonly in the conversion process. Then after, you can treat your nitroalkane. So this is your nitrobenzene and this is your nitroalkane. If you treat it with again SN plus HCl or Fe plus HCl, this will be reduced to a primary amine. Lastly, we can also reduce your nitrile group to your primary amine. For that, we can use H2Ni or NaHgC2H5OH. They will give you the same product, which is primary amine. So in all of these three cases, you are getting primary amine as your product. Next, this reduction of nitriles to primary amine, which is using Na and alcohol, is known as Mendeus reaction. This last reaction is known as Mendeus reaction. Now, if I talk about the oximes of aldehyde and ketone and primary amides, they can also be reduced to form the corresponding primary amine. How you can reduce primary amides? For that, we can use LiLH4. So, LiLH4, once it is acting upon primary amides, it will give you the corresponding primary amine. Next, as I said it earlier, here we have used LiLH4 upon your amide, and in the presence of water, it is giving us the corresponding amine, primary amine. Then we can also reduce your ketoxime. It can be aldooxime or ketoxime both, meaning that you can keep H also here in place of R. Then upon treatment with LiLH4 and ether, you will get it as primary amine. Got it? How is the mechanism? How the H minus attacks here? So it simply attacks on the double bonded carbon and then moves this double bond onto nitrogen, which is being eliminated at the last to give you the corresponding primary amine. And you can also use NaC2H5OH to carry out this reaction. Is it clear to you? So this is about your reactions in which we are reducing alkyl nitriles, nitroalkanes, oximes of aldehydes and ketones, and primary amides. So for alkyl nitrile, what are we using? We are using the reducing agent. Okay. Similarly, for nitroalkanes or nitrobenzene, we are using H2PD. Got it? Then what about oximes of aldehyde and ketone? So in this case, we are using LiLH4 and ether. And in the case of your ketones, we are using LiLH4 and H2O. Rather than using LiLH4 ether, we are using LiLH4 and H2O. But remember, this is occurring in two steps. So first we are acting the LiLH4 onto the amide. Once it is reduced to alcohol, then we are treating it with the H2O to completely transform it into the primary amine. Got it? Moving on to the next preparation method, which is Hofmann's ammonialysis method. In this, we take an alkyl halide and we just treat it with alcoholic solution of ammonia. And this all is done in about 393 Kelvin. But the problem with this process is that we will get a mixture of amines. Rather than getting a specific amine, we get a mixture of amine. How does the reaction goes on? So it is simply a nucleophilic substitution reaction. We can start from here. Suppose we are starting from this part. Then RNH2 is reacting with Rx. What will happen here? Your N will attack on R and your X will be removed. Got it? As a result of this, we are getting R2NH. It is a simple nucleophilic substitution where we are substituting your H with an X. Then coming on to the next part, once this thing is formed, which is a 2-degree amine, then it will react further. So this process goes on. Again, nitrogen will attack on the other molecule of Rx and then we will get a tertiary amine. Lastly, it will result in the formation of quaternary ammonium salt, which is R4N plus and X minus. So this method is not used often because of its mixture that we get at the end of the complete reaction. Now, you can obtain your free amine by your ammonium salt if you treat it with a strong base. So here is the corresponding reaction. We are treating our ammonium salt with NaOH to give us RNH2 and H2O and Na plus and X minus. Is it clear to all of you? So in this way we can get our corresponding amines. Now moving on to the next reaction, which is Gabriel phthalimide synthesis. What do we do in Gabriel phthalimide synthesis? In this, we treat our given phthalimide with KOH, ethanolic KOH. Then what will it do? It will abstract the proton. After that, once potassium salt of phthalimide is formed, then we treat it with the RX, which is your alkyl halide, and then what you can do is hydrolyze it to give us the product, or you can also hydrogenolyze it. So hydrogenolyze means treating with hydrazine, NH2, NH2. Let us see the reaction. So it's very simple to understand. Here you have the OH group. This OH will act as a base and pick up the H from here. That will result in N minus and K plus. Why it is done? It is done to increase the negative charge on nitrogen so that it can be a much better nucleophile. Okay. Of course, a lone pair is weaker than a complete negative charge. So that is something which is occurring here. Now this negative charge is capable of attacking this RX and kicking out this X group from here, creating KX salt, which is a salt of potassium along with a halogen. Here we are getting N-alkyl phthalimide because your nitrogen is being substituted. We have removed the H and introduced an R, so we are naming it as N-alkyl phthalimide. Then after, we will treat it with a base. What will this base do? This base is taken in aqueous solution. Remember, there are two conditions for a base to do the reaction. It can act as a nucleophile or as a base as well. If you are using alcoholic condition, then in most of the cases it will act as a base. But if you are using the aqueous solution, your OH minus will act as a nucleophile. And what is the nucleophilic center which is available? The most obvious center is your CO. First, it will attack one of the CO and the bond between your carbon and nitrogen will be broken. Then it will attack the another CO. Then another bond will be cleaved. Therefore, this NR part will be removed or cleaved away from this N-alkyl phthalimide, resulting in the formation of 1 degree amine. Okay. So this is the overall process. So here your OH type base, so whether it is KOH or NaOH, is used in two ways. In the first case, you have used the ethanolic KOH to make it act like a base. In the second case, we are using the aqueous KOH, means you are using in the presence of water. Your NaOH is dissolved in the water. In that case, it is acting as a nucleophile and hence removing the R N group from the complete phthalimide to give us the primary amine as RNH2. Remember, this process can only be used for creating primary amines because it cannot create secondary and tertiary amine, and this is very obvious from the starting phthalimide as well, right? You are always removing only one hydrogen. There is only one ionizable hydrogen which is present, and that is substituting your nitrogen only one time. Got it? So there is no possibility of creating a secondary amine. So this is very, very important to remember. Okay. One more important point which you should remember is that you cannot have a R group here, which is equals to benzene. Okay. So this R can never be a benzene. Why I am saying it? Remember, in the start of your halogen chapter, we have talked about this. Whenever you are seeing aryl, I would say haloarine. So in haloarenes, nucleophilic substitution is not possible. And in the second step, we are seeing a nucleophilic substitution. If you put a aryl group here, then it will not be favorable at all and the reaction will not proceed further. Means this N minus is not proper to attack on this aryl containing R group. Okay. Therefore, it will not give you the reaction. So this R must be a alkyl group or aliphatic chain only. Then and then only you will get the product. And the only product which is possible is your primary amine. I hope this is clear to you and it's very important to remember. So 2 points you will remember. It helps us to prepare only primary amine. And second thing, it cannot be used to prepare a aniline, or you can say a derivative of aniline, in which R group here is taken as benzene. Moving on to the Hofmann bromide degradation reaction. As the name suggests, we will degrade the molecule by removing one carbon atom. And how this reaction goes on? First of all, we take the amide and then we react it with Br2 in aqueous or ethanolic solution of NaOH. Remember, we have done a previous reaction where we used amide and got our amine. But in that case, the number of carbon was not changing. We are using the LiLH4 ether, sorry, LiLH4 and water. So in the first step, we are using LiLH4 and then we are using water. So that was giving us the corresponding amines from the amides. But if you want that your corresponding amine has one carbon less than the parent amide, then you will use Br2 in aqueous or exenolic solution of NaOH. Again, here also we'll get that same 1 degree amine. Here we have the reaction for the same. See, we have taken RCONH2 and we are treating it with NaOH and Br2. After the reaction, you will see that this CO group is being removed at all. Now, the resulting amine that we are getting has one less carbon than the starting amide, and that is going on to Na2CO3 plus NaBr plus H2. So you will remember this always, that you will get an amine which has one carbon less than the amide. For getting the same number of carbon, you have to use a reducing agent such as LiLH4, and that will give you the same number of carbon as of your amides. Then moving on to schematic reaction. In a schematic reaction, you take a carboxylic acid and you heat it with hydrazoic acid, which is N3H. Got it? All of this is done in the presence of concentrated sulfuric acid, and it gives us a high yield of primary amines. So this is your reaction. Here we have taken a carboxylic acid, and again we are getting an amine which has one carbon less than the carboxylic acid with which we have started the reaction. And where is that carbon going? That is released in the form of carbon dioxide, whereas your N3 is being converted to N2. Okay, so this is your overall reaction. Now, how would be this reaction going on? What is the possible way for this reaction? Now, in this reaction, the first step would be your N3 minus. So that is doing your whole thing. Okay, and this heat is removing the carbon dioxide from the given molecule. Now, if you want, in place of N3H and concentrated H2SO4, you can also use NaN3 and concentrated H2SO4. Both of them will give you the corresponding reaction. Got it? So this is your schematic reaction. Here also we are starting from a carboxylic acid and we are getting an amine which has one carbon less than the starting point. Now we'll talk about the physical properties such as physical state, order, solubility, boiling point of amine. Talking about that, your lower aliphatic amine have fishy odor, and your aniline and your other alkyl amines are usually colorless because they develop color on keeping it in air for a long time, and that is occurring due to atmospheric oxidation. So it is a quite simple point. Next, what about the boiling point and solubility? So you know it very well that boiling point decreases on increasing the branching, and the solubility also decreases on increasing the branching. The primary factor for your amines to be dissolved in water is the hydrogen bonding between the hydrogen of your amine and the oxygen of your water. So here is your result as a result of the same. So the 1 degree amine is much more soluble because of the presence of 2 hydrogen that are available for hydrogen bonding. Then in 2 degree amine, we have only 1 hydrogen available for hydrogen bonding, and in 3 degree amine, we have no hydrogen available for hydrogen bonding. Remember, for your hydrogen to get participated in your hydrogen bonding, it should be coordinated to either nitrogen or fluorine or oxygen. Then and then only it will be capable of showing hydrogen bonding. In the case of last compound that you are seeing, the tertiary amine, your hydrogen is attached with the carbon and not with the nitrogen. Hence, it is not capable of showing hydrogen bonding. Remember, amines will always have a lower boiling point corresponding alcohol. Why is it so? Because alcohol has a much more electronegative oxygen, and that creates a stronger hydrogen bonding. Okay, and as a result of that, amines have always lower boiling point than the alcohol. So this was all about the theory part. Now we will move on to the question. So if you have a doubt, you can post it now in the comment section. Meanwhile, I would be opening the question part. So here is the first question. Reduction of aromatic nitro compound using Fe and HCl gives us. We have seen this reaction in the starting part of your preparation of amine. We have 4 options present here: aromatic oxime, then aromatic hydrocarbon, aromatic primary amine, and aromatic amide. So you have some time to solve it. Just try it by yourself and give your answer in the comment section. So what will be the answer for this question? You have to simply say that what will be formed upon reduction of nitro compound with Fe and HCl. Anyone? Can you tell me the answer? Okay. So the correct answer would be aromatic primary amine. Now, if you treat your given nitrobenzene with FeHCl in the presence of your C6H5NO2, then it will give you an aromatic amine, which is C6H5NH2. This is the final product. Next question. Yes, option would be C. Then, in which of the following reaction tertiary amines is obtained? Okay. A. Aniline is reacting with CH3I 2 times. Second, aniline is reacting with CH3I 1 time. Then nitrobenzene with SnHCl, and then none of this. You have to tell that in which of this we will get tertiary amine. So it's a easy one. So it is directly from your 2 parts. So in the first part we have this reduction thing, and in the second part it is from Hofmann ammonolysis reaction. Today we will also do some PYQs of the same chapter regarding our recent year. So just stay tuned. Just we'll deal with this question part, and then we'll move on to the PYQ section. Yes, the correct answer will be A. So I'm getting an answer. Anyone else who likes to give the answer for this question? Option A. Okay. So let us go with this option A. It's an easy one, so I won't give much time for it. Yes, the correct answer would be A. So in this case, what is happening? You are doing nucleophilic substitution reaction, and that is occurring 2 times. So first of all, your N will attack the CH3 and will remove the I from this. Got it? And this will result in the formation of secondary amine. Then your secondary amine will again react with the CH3I to give you the tertiary amine. What about other reactions? So if I talk about one of them, which is the second one, option B. So if your C6H5NH2 reacts with CH3I directly, then it will give you N-methyl aniline, because in this case your nucleophilic substitution is occurring only one time. Then after, the third reaction that we have is the reduction of your nitrobenzene in the presence of SnHCl, or you can also use FeHCl. Both of them will give you the same aromatic primary amine. We have seen this reaction. Moving on to the next question. The major product of the following reaction is. Now here, this question that you are seeing right now is a very good example of applying what you have learnt about the Gabriel phthalimide, because there is a possibility of getting 2 types of product. First of all, what will happen, you know it very well. Your base that is present here, it will abstract a proton from the nitrogen, creating a negative charge on nitrogen, and then after this negative charge can attack on 2 parts. Either it can attack on the bromine and remove this bromine, or it can attack on the CH2Cl to remove this Cl. Now question arises, which is more prone to attack? Remember, we have talked about this. So keeping that thing in mind, just tell me what will be the correct answer for this question. Just write it in the comment section. So 4 options are given here. In the first option, your N is attacking upon the CH2Cl. It's very clear. In the second option, it is attacking upon the Br. In the third option, we are getting something else, and same for the fourth option. So can you tell me what will be the correct answer for this? Remember, your nucleophilic substitution is not favorable for aromatic halide containing compound in which halide is directly attached to the benzene ring. So I am talking about haloarenes. Nucleophilic substitution is not favorable for haloarenes. Can you tell me what will be the answer for this question? It's an easy one. Okay, so let me tell you the answer. The correct answer would be option A. Let's see if it is correct or not. Yes, the option A is the correct one. And how is it possible? So this is simply your Gabriel phthalimide synthesis. Remember, your nitrogen that you are giving the responsibility of attacking your alkyl halide can only attack on that halide which is not attached to benzene. Okay, so here first of all your OH minus will remove from hydrogen from nitrogen, and next this nitrogen lone pair is being stabilized in the whole ring, and that is the reason your hydrogen is getting detached from the nitrogen. After that, your nitrogen will attack on the CH2Cl because SN2 mechanism is not possible for this CBr bond because it has a double bond character, right? You remember this, that the lone pair of bromine is being delocalized, and also your carbon is sp2 hybridized and it is not suitable for SN2 reaction. Therefore, the attack will happen on the CH2Cl. After that, once this thing is broken, you are getting your answer as ClCH2, then the benzene ring, and then the Br. See, it is written here also that SN2 reaction is not possible on the carbon which is containing bromine because this bond between carbon and bromine is partially double bond due to the resonance effect. Moving on to the next question, question number 4. So, the best reagent for converting 2-phenyl propanamide 2 into 2-phenyl propanamine is. Options are A. Excess H2, B. Br2 in aqueous NaOH, C. Hi in the presence of red phosphorus, and D. LiLH4 in the ether. Here you can do a very simple mistake of assuming that this conversion is regarding your Hofmann degradation reaction, but it is not so because the number of carbon is not getting reduced. It is same as the starting material. You have to reduce it in such a way that the number of carbon is retained and your amide group is converted into amine. So you have some time to give the answer. Just write your answer in the comment section. I would expect more answers from you. Anyone, can you tell me what will be the correct answer? What will be the answer for this question? Can you tell me? So Varsha Khare or anyone else? So option B, just think about it again. You have you can, if you just apply this Br2 in aqueous NaOH, then this would be Hofmann degradation. In Hofmann degradation, your carbon count is reduced by 1. And in the product, if you see that the carbon count is same, if you just try to draw the structure of 2-phenyl propanamine and 2 propanamide, then both of them will have the same count of the carbon. We have talked about another method of converting our amide to amines, and that was done by a reducing agent, and we have a reducing agent in the option. So can you tell me what will be the correct answer then? So moving on to the correct answer, it will be D, LiLH4 in ether, right? So what we do in this reaction, we take this LiLH4 in ether, this H minus from this LiLH4 will attack on the carbonyl center and reduce it to this amine group. Got it? But if you take the Hofmann degradation in place of this, what will happen? This CO group that you are seeing right here will be removed, and the product we will get it as 1-phenyl ethyl amine. Got it? So remember, you won't do the mistake multiple time. First of all, read this question properly, that here is no reduction in the count of carbon. Therefore, you will use such a method that does not reduce one carbon from the starting material, and hence you will use this LiLH4. Now moving on to the next question. Acetamide is treated separately with following reagents. Which one of these would give methylamine? Options are A, PCl5, B, NaOHBr2, C, soda lime, and D, hot concentrated H2SO4. Can you tell me what will be the correct answer? Now, this question is something which is related to Hofmann degradation, and you can easily give the answer here. I would request you to give one more answer. Uh, so, how many moles of NaOH you will use in this reaction? If you have seen the reaction properly, you must have noticed the number of moles as well. So, can you tell me what will be the number of moles? 4 moles. Yes, 4 moles of NaOH Br2 is used, right? And in place of NaOH Br2, you can also see NaOBr. Got it? You can also see NaOBr rather than writing this whole NaOH Br2. You can also see NaOBr. Now, after the reaction, this will result in degradation part, and according to that, the correct answer would be option B. So, this is your complete reaction. Your acetamide on treatment with NaOH and Br2 will give the methylamine, which is an example of Hofmann degradation. Now, in place of this, if you use PCl5, then it will result in the formation of 2,2-dichloroethanamine. Moving on to the next one. Suppose we use this hot and concentrated H2SO4. So that would give you ammonium acetate. And lastly, if you use LiLH4, then it will just reduce it simply to ethylamine and not to methylamine, because in this process we cannot reduce the count of carbon by 1. Now moving on to the next question. So this was asked in JEE Mains in 2016. So remember, we have talked about this, and that is the same question that I asked you right now. In the Hofmann bromide degradation reaction, the number of moles of NaOH and Br2 used per mole of amines produced are. So 4 options are here. A, 4 moles of NaOH and 2 moles of Br2. B, 2 moles of NaOH and 2 moles of Br2. C, 4 moles of NaOH and 1 mole of Br2. And D, 1 mole of NaOH and 2 moles of Br2. So it's a very easy question. We have talked about this. What will be the correct answer for this question? Yes, the correct answer would be C, NaOH and 1 mole of Br2. Anyone else? What will be the correct answer for this question? Can you tell me? Just try to write the complete reaction. Then you will get an idea what will be the correct answer. Okay. So I will take that option C will be the correct one. Okay. Yes, 4 moles of NaOH and 1 mole of Br2. If I write the complete reaction of Hoffman bromide degradation, then this it would be. Here you can also remember the number of moles of product which is being formed. Remember, you will get 2 moles of NaBr, 2 moles of H2O and 1 mole of Na2CO3. So I also got this question when I was giving my boards exam. Okay, where I was asked to write the number of moles of product, and this is something which can be asked in the JEE exam as well. Now, moving on to the next question. Question number 7. The major product of the reaction between M-dinitrobenzene and NH4SH is. So this is an interesting one. You can just try it by yourself. I have not given a clue before in the theory part. So you will first take M-dinitrobenzene, means nitrogen is present at two parts and they are at a relation of 1:3, right? And you have to treat it with the NH4SH. What will be the product for this reaction then? Anyone, can you tell me what will be the product for this reaction? Now remember, this NH4SH you are seeing here is a salt that is consisting of NH4 plus and SH minus. Got it? And this NH4 plus is capable of accepting electron because it is containing a positive charge. Now think about it. What can be the possible product? Anyone who got the answer for this question? So again I am repeating my question. The major product of the reaction between M-dinitrobenzene and NH4SH is. Okay. So you may think that this NH4 plus will act as a electron accepting one and it may accept electron from the benzene. But remember, your nitrogen has already completed its thing. It cannot accept electrons further. Got it? So certainly it will not give this product C, which is not possible at all. Right? So once you are talking about NH4 plus is already making 4 bond, it is not capable of making the fifth bond. Got it? Now think of other possibilities, right? So this C and D option is being already being removed. We are left with A and B. Now, out of this A and B, there is a confusion that what is occurring due to this NH4SH. So this is basically a reducing agent. It will reduce your compound and it has a selective reduction. It will only reduce it one time. Therefore, the correct option would be B. Got it? Yes. It is known as xenin reduction. So once you treat your dinitrobenzene with NH4SH, then one of the nitro group is reduced to NH2. Moving on to the next question. So this was asked in JEE Main 2013. An organic compound A on reacting with NH3 gives B. On heating, B gives C, and C in the presence of KOH reacts with Br2 to give CH3CH2NH2. Now you have to determine what is this A. So think about it. Your time starts now. So it's a very easy one. You just have to see that which type of reaction is going on here. You can start it from the end also, means from the CH3CH2NH2 also. You can just go back from this part and you will get your answer in a very easy fashion. Anyone, can you tell me what will be the correct answer for this question? What will the correct answer for this question? Okay, so let us move on to the correct answer. The correct answer would be option D, which is CH3CH2 double COOH. Now in this reaction, if I start from the first part, which is NH3, so we have a base here and then we have an acid here. What will happen? This acid that you are seeing, it will donate one proton onto the NH3, and that will result in the formation of a salt, which is CH3CH2CO double minus and NH4 plus. Now on heating this salt, you will just remove one molecule of water, that means H2O, and that will give you the corresponding amide. Lastly, you can just treat it with Br2KOH to give us the corresponding primary amine. Now I told you that you can get the answer if you start it from the end part. How? So first of all, from here what you can get is the corresponding amide, which is CH3CH2COONH2. Then on heating, if you are removing on water, on moving on to the backward process, you will add one H2O, and that is only possible if you are starting it from the carboxylic acid. So you will get an idea once you start it from the end, because the compound's composition is somewhat given in the end part. So this was all about the question that I prepared. So now we'll do some more recent PYQs. So just wait for a while. I will just open those PYQs. So here is the first question, which was asked in year 2023 and sorry 2024, and it was in the 29th of January in the shift 2. Now, if you look upon the question, this would include some of the topics from your previous concepts as well regarding the formation of your diazonium and all. Here is the question: the product A which is formed in the following reaction is. So let us start doing it. So first we have taken aniline. Before moving on to the solution, can anyone tell me that what will be the okay. So can anyone tell me what will the correct answer for this question? So first we are starting from the aniline. Now in the first reaction what will happen? Here it will result in the formation of diazonium salt. So that is very obvious. This is the first step, which is reaction with NaNO2 and HCl and 0 degrees Celsius. So once you do this, it will result in the formation of N2 plus and Cl minus. Got it? Now, next what will happen? Once you got this, you will treat it with CO2 Cl2. Okay. Now it's very obvious what will be the product. It will result in the formation of chlorine in the place of N2 plus Cl minus. That means chlorobenzene will be your correct answer. Got it? So if you just move with that thing, then the correct answer would be option 3, which is chlorobenzene. Now let us see the solution as well. Here it's very simple. So first what are we getting here? We are getting the diazonium salt, and then on treatment with CO2 Cl2 we are getting the chlorobenzene. Now moving on to the next question. Here in this question you have to tell me that during this test, which is a confirmatory test for aromatic primary amines, we are starting with NH2 attached to the benzene, which is aniline. Then what are we doing? We are treating it with A. Now that A would be obviously your NaNO2HCl 0 to 5 degrees Celsius, which is given in option number 2. And if you just look down, it is given in option number 3 and 4 as well. Right? Now this 3 can be your correct option. Well, we have to decide that what will be the resultant B here. So here we are treating it with NaOH. Can you tell me what will be the product then? Yes? Anyone? So first of all, what we are doing? We are treating it with NaNO2 and HCl. So that is resulting in the formation of N2 plus Cl minus. Now then we are treating it with the naphthol, which will result in a coupling reaction. So basically this N2 plus Cl minus will couple with this naphthol and it will result in the formation of red dye. And this is known as your test for your primary aromatic amine. Got it? Moving on to the next question. In this question, you are given actually 4 steps in total. If you look closely, you will see 4 steps. What are those 4 steps? So in the first step, we are treating our given benzene with the concentrated HNO3 and concentrated H2SO4. So this is your nitrating mixture. So first of all, if you treat it with HNO3 and H2SO4. So this was asked in 2024 in the 30th of January in the shift 2. Then it will result in the formation of nitrobenzene. So this is your first product. Then after that, we are treating it with SnHCl. This is your reducing agent. So it will reduce your given nitrobenzene into aniline. Here we will now get NH2. Next, what will happen? Next, in this, according to this, what will be the correct answer for A? What will be the A here? It will be option. It will be according to option 2, 3, or 4. So in on all of these three options, what are we seeing? We are seeing a NH2 group attached to the benzene ring. Now we have to decide it for the B. For the B, we have to start with NaNO2HCl. Again, that same thing. So you can clearly see that most of the times the question is coming from the formation of diazonium salt. So first, if I treat it with NaNO2HCl in 0 to 5 degrees Celsius, then it would result in the formation of N2 plus Cl minus. Okay, here we will get N2 plus and Cl minus. Again, we will treat this thing with our next, which is phenol. Now what does phenol does here? Phenol does a coupling reaction. Okay, it does a coupling reaction. You know it very well. This coupling reaction will result in the formation of an coupled product in which 2N will be present in between, and here it will be your OH group. According to this, what will be the correct answer? It will be option 3. Got it? So let us just check for the same. Yes, the correct option is option 3, and you can look at here also. First, we are treating it with nitration mixture to give the NO2. Then we are using the SnHCl. Further, we are converting into diazonium salt, and lastly, we are coupling it with the OH. So moving on to the next question. So in this question, you have to say that, so it is a statement based question. Question is saying that amines react with H2SO4 by heating at 453, 473 Kelvin to give para-aminobenzene sulfonic acid. Then it gives us blood red color in the Lessing test. Then it is asked that in Friedel-Crafts alkylation and acylation reaction, aniline does not form a salt with AlCl3 catalyst. Due to this, nitrogen of aniline acquires a positive charge and acts as a deactivating group. So in the light of the above two statements, choose the correct option. We know that in the Friedel-Crafts alkylation acylation, alkene does form a salt. So it is written wrongly here. Got it? So obviously this statement is incorrect, because it is telling us that it is not forming a salt. But yes, it is forming, it is resulting in a deactivating group. Once, as soon as this N is reacting with AlCl3 to form the salt, it is acting as a deactivating group. Now, if you just look at the answer, then it is clearly saying that your correct answer will be option 4. Now we'll do some more questions. Say we do it for 2023. So all of this is present in our website. You can just check out there. Suppose we go on to this amines. So here are total of 11 questions from that year. So we'll just try to attempt each of them one by one. Here is the first question. Choose the correct color for the product for the following. So we are starting with N double bond N OOCCH3 SO3H, and we are treating it with 1-naphthyl phenylamine. You can also refer to our answers as well. So what will happen? First of all, there will be a coupling reaction. Okay, so here two things will get coupled to each other, and it results in the formation of scarlet red color. As soon as you see this thing, remember it will always have a scarlet red color. Next question. So there are two statements which are given here. Pure aniline and other aryl amines are usually colorless, and aryl amines get colored on storage due to atmospheric reduction. You know it very well. It happens due to atmospheric oxidation, okay, not reduction. So first statement is correct, but the second statement will be atmospheric oxidation. Therefore, statement 1 is correct and statement 2 is incorrect. Moving on to the next question. So here are a series of reactions. We'll start with the first one and move on to the last. Let us start from the first part. First of all, we have methyl here present on the ring, which is like this, and a NO2 group attached to it. Now we are treating it with the Br2. What will happen as a result of this? First of all, this Br2 that you are seeing here, it will be introduced into the benzene ring. Now the question is that what are the possible positions? According to this methyl group, ortho position is suitable, that means this one, and according to this NO2 group, meta position is suitable. Now since both of them are just orienting it to the second position with respect to methyl, therefore you will introduce your Br here. Got it? Now next what will happen? You are just reducing it. You are using SnHCl. This will result in methyl here, NH2, and then Br here. Okay. What is the next step? It is NaNO2HCl. Okay. In 0 to 5 degrees Celsius. So that will result in the formation of N2 plus and Cl minus. So here we will get N2 plus and Cl minus. After that, we are treating it with H3PO2 and H2O. So in this, we will get OH in place of N2 plus Cl minus. So here now we will have OH and here we will have Br. Lastly, what are we doing? We are treating it with KMnO4 and KOH. So that is very simple. It is an oxidation reaction that will oxidize the whole thing into carboxylic acid. Here it will be Br and in the end part we will have OH. According to this, the correct answer would be option 4th, right? I hope this is clear to you. Moving on to the next question. Here we are being asked that in aqueous medium, what is the correct order of basicity? Now, it is methylamine, right? And then we are moving from 1 degree to 2 degree to 3 degree. So there is an order. If the methyl group is attached, then the order in the aqueous medium is 2 degree, then 1 degree, and then 3 degree. If ethyl group is attached, in that case, the order goes as 2 degree, then 3 degree, and then 1 degree. So this is something which you should remember. Here it will be 1 degree. Okay. Now, since methyl group is attached here, so first we will have 2 degree. So this one, then 1 degree, and then 3 degree. Are there any more options which are of the same order? Let's see. Here it is 3 degree starting. This is wrong. This is also wrong. Okay, so the correct answer would be option 1. Moving on to the next question. In the next question, you have to say that reduction of propanamide with Br2KOH produces. So it's a very simple one. If you treat it with Br2KOH, it will result in the formation of ethanamine, right, which is C2H5NH2. Therefore, the correct answer would be Option 4. So here we have the common name ethylamine rather than the ethenamine name. So this is a match the following type. So I'm writing it for you in a clear manner since it is very small. First option is saying that if we treat our chlorobenzene with CH3Cl in the presence of Na, then what it will result in? It will result in the formation of toluene because this is a Woods reaction. Okay. So here we will get CH3 attached to it. Moving on to the next one. So this is Woods reaction. Next one, we have two Cls. Now in this case, both are same. Remember, we have two types here. One is Fittig reaction and one is Woods Fittig reaction. Now you have to decide that in which one we have the same molecule being coupled together and in which one two different molecules are coupled together. So there is a small difference. Can anyone tell me what is so in which one you will get the same two molecule getting coupled together and which one will get the different molecule? So in Woods Fittig reaction, you have alkyl and aryl. So this is your Woods Fittig. As I said earlier, it is Woods Fittig reaction. Whereas in the second case, we will have Woods reaction. Moving on to the next question. If I just write it, next option, it is given here as N2 plus Cl minus in the presence of Cu2Cl2. So this will result in the formation of chlorobenzene. It's an easy one. We have seen it in the starting part also. Last one, C2H5. So this is what? This is your Sandmeyer reaction. You know it very well. It is your Sandmeyer reaction. Last, C2H5Cl plus NaI. What it will give? It will give you C2H5I plus NaCl. So there are two reactions in which halide is being exchanged. So one is Schwarz reaction in which alkyl fluoride is formed. In this case, alkyl iodide is formed and this is known as Finkelstein reaction. Okay. Now, according to this situation that we are seeing, so A would be 2, then B would be 1. What about C? C would be 4 and your D would be 3. So 2, 1, 4, 3. 2, 1, okay. 2, 1, 4, 3. So the correct option would be option number 4th. Moving on to the next question. Okay. So this was asked in January, shift 2, 30th January, shift 2. Question says that, so this is our last question for today's class. Then we will start our maths class after this. Now this is a conversion process and you have to see that which of the reagents that you will use that will give your appropriate product. So first of all, it is given that you are given a CH3NO2, okay, and then you have to convert it into CH3Br at 2 positions, okay. How you will do it? We will start from the suppose first one. What will happen in this? This will put your CH3. So let me draw it properly. So here we have a CH3 and we have a NO2. If you just directly treat it with Br2Fe, then where will the Br go? It will go at the ortho position of CH3 and NO2's meta position. That means Br will be attached here. Now from this single step only, we are very clear that this would not be the correct option because we need Br at meta position of CH3. Okay, you can see it very clearly that Br is present at the meta position of CH3. Now, what is the next one? We are starting with Br2 aqueous. So what it will result in? Then we have LiLH4 and then we have H3O plus. Okay. Can anyone tell me what will be the correct answer? Okay, so we are lacking time. So we have a maths class right now. We will do it tomorrow. Thank you for joining the session. I hope you enjoyed it.
Hello everyone, good evening. Okay, so in today lecture, we will discuss about ellipse. Okay, this is disclaimer. So, at first, we will study the concept of an ellipse. Okay, then equation of ellipse in its standard form and what is tangent to an ellipse and what are the different form of equation of tangent to the ellipse. Okay, Then we discuss some result related to the tangent of one ellipse. Then normal to an ellipse, and we will look at results on normal. Then what is auxiliary circle for an ellipse, and then we will study about the eccentric angle of a point for ellipse. What is conjugate diameter, and then we'll discuss some result on conjugate diameter, and then some important points. Okay, and after that we discuss some question on ellipse. So let's start. So what is ellipse? So ellipse is the locus of point such that point in a plane which moves in a such a way that the ratio of its distance from a fixed point in the same plane to the distance from a fixed straight line is always constant, and which is always less than unity. So see this figure. So we have a point P. So locus of this point P is an ellipse if the distance of this point with a fixed point S, that is your focus, and the distance of this point with this fixed line, that is called directrix. So when we take the ratio of the distance, we get a constant ratio to get a conic section, and we get that conic section as ellipse if the constant ratio is always less than unity. Clear? So now equation of ellipse in standard form. So what is the equation of ellipse? So equation of ellipse is in standard form is x square by a square plus y square by b square is equal to 1, where b is lies between 0 and a. That means b is less than a. Okay. So this is the standard form of equation of ellipse. Okay. So as we see, b is less than a. So the coefficient of x square has the larger denominator. That means a square is greater than b square. Then this type of ellipse is called horizontal ellipse, and in this case the major axis for this horizontal ellipse is x-axis. Okay, so if a square is greater than b square, that means coefficient of x square has a larger denominator than the coefficient of y square, then this ellipse is called horizontal ellipse, and in this particular case the major axis is lies along the x-axis. Okay, so this is the figure of horizontal ellipse. Okay, so let's discuss each part of this ellipse, this horizontal ellipse. So various elements of this horizontal ellipse are: first, center, that is 0, origin. So 0 comma 0, where the major axis and minor axis intersecting, that point is center for the ellipse. Okay, next, the vertices. So the point A and A1, that is the coordinate of this vertex given by a comma 0, and A1 is minus a comma 0. Okay, next, major axis. So as this ellipse is horizontal ellipse, so major axis lies along the x-axis. So the x-axis is major axis, and equation of x-axis is y is equal to 0. So major axis for this horizontal ellipse is y is equal to 0, that x dash line. Okay, now the minor axis, the y dash line. So this is a minor axis, y axis. So equation of y axis is x is equal to 0. So for horizontal ellipse, major axis is x axis and minor axis is y axis. Okay, next is focal distance. So let's suppose we have a point on a ellipse, that point is P, x comma y, and the focal distance is given by a plus minus ex. Okay, where e is eccentricity of this ellipse. Next is major axis. So as major axis is x-axis, so the length of this major axis is AA1, and that is 2a. Okay, as we know the vertices, that is a comma 0 and minus a comma 0, so we can also find this distance by distance formula. So a1 is 2a, and the length of minor axis, that is bb1, is 2b. Okay, the coordinate of b is 0 comma b, and coordinate of b1 is 0 comma minus b. Okay, now an ellipse has two focus. Okay, first is s1 and second is s1. The coordinate of s is ae comma 0, and coordinate of s1 is minus ae comma 0. Clear? Next, equation of directrix. So we have two directrix for an ellipse, that line L and L dash. So equation of L is given by x is equal to a by e, and L dash is x is equal to minus a by e. So this is the equation of directrix. Clear? So for an horizontal ellipse, center is 0 comma 0, vertices are a comma 0 and minus a comma 0, major axis is x axis, minor axis is y axis, focal distance is a plus minus ex, length of major axis is 2a, minor axis is 2b, focus are given by ae comma 0 and minus ae comma 0, and directrix are x is equal to a by e and x is equal to minus a by e. Okay. Other points, length of latus rectum. So as there is latus rectum, that is LL1, and second latus rectum is L dash L dash 1. Latus rectum is the chord that is passes through the focus and perpendicular to the axis. Okay, so this is your latus rectum, and the length of latus rectum is given by 2b square by a. Okay, where a is length of semi major axis and b is length of semi minor axis. Clear? Important formula. Next, eccentricity. So we can calculate eccentricity by using a and b, that is length of semi minor axis and length of semi major axis and length of semi minor axis. A is your semi major axis and b is length of semi minor axis. So a is given by root under 1 minus b square by a square. Clear? This is also an important relation. Next is sum of focal distance of a point x comma y is 2a. So if we have a point on a ellipse, let's suppose P, and the coordinate of P is x comma y, then sum of focal distances, as there is two focus S and S1, so PS plus PS1 is 2a. Okay, clear? Now ellipse of the form x square by a square plus y square by b square is equal to 1, where 0 a is greater than 0 and less than b. Now a is less than b. Okay, so this is another type of ellipse where the coefficient of x square has the smaller denominator. Okay, so in this case the major axis is y axis along the y axis, and this type of ellipse is called vertical ellipse. Okay, so an ellipse of the form x square by a square plus y square by b square is equal to 1 is called vertical ellipse if a is less than b. That means the coefficient of x square has a smaller denominator than the coefficient of y square. Okay, so this is the picture of vertical ellipse. Okay, so for vertical ellipse, center is same as horizontal ellipse, that is origin 0 comma 0. Okay, now coordinate of vertices. Now vertices lies on a y-axis and it is given by b, that is 0 comma b, and b1, that is 0 comma minus b. Okay, equation of major axis. So now the major axis lie along the y-axis. So the y-axis is major axis and the equation of y-axis is x is equal to 0. So equation of major axis is x is equal to 0, and equation of minor axis, that is y is equal to 0, and focal distance of a point x comma y is b plus minus ey. Okay, next point, major axis. So the major axis of a vertical ellipse is bb1, and that is 2b, and minor axis is aa1, that is 2a. So length of minor axis is 2a, and length of major axis 2b for vertical ellipse. Okay. Next point, focus. There's two focus for vertical ellipse. The coordinate of S is 0, BE, and S1 is 0, minus BE. Okay, where E is eccentricity of ellipse. And equation of directrix are L is given by y is equal to B by E, and the line L dash is given by y is equal to minus B by E. Okay. And same length of lattice rectum same as horizontal axis, that is given by, sorry, length of lattice rectum for vertical ellipses L1 is equal to L dash 1, that is given by 2a square by b. Okay. And eccentricity, that is noted by E, is given by E is equal to root under 1 minus a square by b square in case of vertical ellipse. And the sum of focal distances of a point, any point x comma y, is given by 2b. Okay, so if we have any point on a vertical ellipse, that let's suppose P with coordinate x comma y, then PS plus PS1 is equal to 2b. So this is all about vertical ellipse. Okay. So let's discuss some result on ellipse of the form x square by a square plus y square by b square is equal to 1. So what is the parametric form for equation of ellipse? So the equation x is equal to a cos theta and y is equal to b sin theta. When we take in this together, so this equation are called parametric equation of the ellipse x square by a square plus y square by b square is equal to 1, where theta is the parameter. So now we can write any point on the ellipse by just using a single parameter theta. So let's suppose if we have any point on an ellipse x comma y, then that can be represented by a cos theta, b sin theta. Okay. Next is, if we have any point x1 comma y1, then this point can lie on a ellipse, can be inside ellipse, and it can be outside the ellipse according to the condition on S1. So if S is the equation of ellipse, that is x square by a square plus y square by b square minus 1. If we substitute the point x1 y1, we get S1, that is x1 square by a square plus y1 square by b square minus 1. So according to the value of S1, the point lie inside the ellipse, on the ellipse, and outside the ellipse. So if S1 is less than 0, then the point is lie inside the ellipse. If S1 is equal to 0, then this point is lie on the ellipse, and if S1 is greater than 0, then in this case this point lie outside the ellipse. Okay, clear? Next is locus of midpoint of focal chord on a ellipse. So what is focal chord? A chord of an ellipse that passes through the focus. There is two focus. So if we draw the focal chords and when we take the locus of the midpoint of an ellipse, then that is given by x square by a square plus y square by b square is equal to ex by a. So this is also an ellipse. Okay. So the midpoint, the locus of the midpoint of focal chords of an ellipse is again an ellipse. Okay, and that is given by x square by a square plus y square by b square is equal to ex by a. Okay. Next is, let p and q be any 2 point of the ellipse, and we represent this 2 point by using the parameter. So there is a misprint. The point A is a cos theta, comma b sin theta, and that is this point is represented by parameter theta. And second point is q, that is a cos phi and b sin phi. So this point is represented by angle phi. Okay, so there is a misprint. So let's suppose these are the 2 points of an ellipse x square by a square plus y square by b square is equal to 1. Then if we join the point P and Q, so we get a chord. Then equation of that chord joining these 2 points is given by x by a cos theta plus phi by 2 plus y by b sin theta plus phi by 2 is equal to cos theta minus phi by 2. Okay, clear? Now, what is tangent? So, tangent is a line that touch the curve at a single point. Okay, in this case the curve is ellipse, so we can draw a tangent at any point on the ellipse. Let's suppose we have a point P x comma y, then we can draw the tangent at that point. So tangent at that point is a line that passes through that point and touch the graph at a single point. At that point P is equal to x comma y, and that is your tangent. Okay, and there are different form to write the equation of tangent. Okay, first form is point form. So in point form, x1 y1 form, is the tangent is given by x into x1 by a square plus y into y1 by b square is equal to 1. In slope form, if the slope of the tangent is m, then equation of the tangent in slope form is given by y is equal to mx plus minus root under a square m square plus b square. And where this intersect that curve, touch that curve, the point of contact is given by plus minus a square m by root under a square m square plus b square minus plus b square by root under a square m square plus b square. Okay. In parametric form, the parametric form, if the point is a cos theta b sin theta, then in this form the equation of tangent is x by a cos theta plus y by b sin theta is equal to 1. Okay. So let's discuss some result on tangent to an ellipse. So this is the picture of tangent, that is we have an ellipse and we draw a tangent at a point P x1 comma y1. So first result is the line Lx plus my plus n is equal to 0 is a tangent to the ellipse x square by a square plus y square by b square is equal to 1. So if this line, particular this line is tangent to an ellipse of the form x square by a square plus y square by b square is equal to 1, then it satisfy a condition, and that condition is n square is equal to a square into l square plus b square into m square. Second is, if the line that is in the form of slope intercept form, that is y is equal to mx plus c. So if this is tangent to an ellipse, that is touches an ellipse, passes through a single point to the ellipse, if and only if c square is equal to a square m square plus b square. It means if c square is equal to a square m square plus b square, then the line y is equal to mx plus c touch an ellipse, that is this line is tangent to that ellipse. Okay, and if this line is tangent to this ellipse, then it satisfies the condition c square is equal to a square m square plus b square, and the point of contact is given by plus minus a square m by c comma minus plus b square by c. Clear? Okay. So next result, the equation of pair of tangent. Okay, so now we'll discuss about what is a pair of tangent. So let's suppose we have an external point P x1 comma y1 that is like outside the ellipse. Okay, and we draw tangent from this point to the ellipse. So we can draw two tangent. So we get pair of tangent that is drawn from this point. So that equation of that pair of tangent is given by s into s1 is equal to t square, where s is x square by a square plus y square by b square minus 1. S1 is x1 square by a square plus y1 square by b square minus 1. And what is t? T is x into x1 by a square plus y into y1 by b square minus 1. So with the help of s, s1 and t, we can write the equation of pair of tangent, that is s into s1 is equal to t square. Okay. Next is equation of chord of contact of tangent. So when we draw two tangent from external point, it intersecting at 2 points, okay, to the ellipse, and when we join that 2 point, we get a chord of contact of tangents, okay, and the equation of this chord of contact of tangent is given by x into x1 by a square plus y into y1 by b square is equal to 1, that is t is equal to 0. Okay, as t is x into x1 by a square plus y into y1 by b square minus 1. Okay, next is equation of a chord of an ellipse. So we draw a chord of an ellipse whose midpoint is x1 y1. Then equation of this chord of an ellipse is given by t is equal to s1. And what is t? That is x into x1 by a square plus y into y1 by b square is equal to s1. And that is x1 square by a square plus y1 square by b square. So this is the equation of chord of an ellipse whose midpoint is x1 y1. Okay. Next is director circle. So as I already defined the director circle in case of parabola, in case of circle. So what is director circle? So if we draw two tangent to ellipse and the both tangents are perpendicular tangent, that means angle between these two tangent is 90 degree, then the locus of the point of intersection of this perpendicular tangent to an ellipse is the director circle. Okay, and that is x square plus y square is equal to a square plus b square. So for ellipse, director circle, equation of director circle is x square plus y square is equal to a square plus b square. Okay, now we draw tangent at alpha and beta. So alpha and beta are the parametric angle which represent 2 points on ellipse. So point of intersection of the tangent at alpha and beta is this. So when we draw two tangent at a point at a 2 point of ellipse that is given by the parameter alpha and beta. So the point of intersection of this tangent is given by a cos alpha plus beta by 2, b by cos alpha minus beta by 2, b sin alpha plus beta by 2, cos alpha minus beta by 2. Okay. So these are the result on tangent, pair of tangent and chord of contact. Okay. Next is normal. So what is normal? Anyone define normal? So how we can define normal? So let's suppose we have a curve, we have an in this case ellipse, and when we draw a tangent that is passes through a single point of an ellipse, then when we take a perpendicular line to the tangent, that line is normal to the ellipse. Okay, so there are different form to write the equation of normal for an ellipse. That first is point form, and that is equation of normal in point form is a square x by x1 minus b square y by y1 is equal to a square minus b square. Okay. Second, in slope form, so equation of normal in slope form is given by y is equal to mx plus minus m into a square minus b square by root under a square plus b square m square. Okay. And the point of contact of normal is plus minus a square by root under a square plus b square m square plus minus b square m by root under a square plus b square m square. Okay. In parametric form, the equation of normal, in parametric form, that means in the form of a cos theta b sin theta, where the equation is given by in just using one parameter, that is theta, then that is ax sec theta minus by cosec theta is equal to a square minus b square. Okay. And the point of intersection of normals. So now we draw two normals at 2 points on an ellipse. First point is a cos theta 1 b comma b sin theta 1, and second point on ellipse is a cos theta 2 b sin theta 2. This point are given in the parametric form with the using a angle theta 1 and theta 2. So now we draw two normals at this 2 point. So the point of intersection of these two normal is given by lambda mu, and lambda is a square minus b square by a cos theta 1 into cos theta 2 into cos theta 1 plus theta 2 by 2 by cos theta 1 minus theta 2 by 2, and mu is given by minus a square minus b square by b sin theta 1 into sin theta 2 into sin theta 1 plus theta 2 by 2 cos theta 1 minus theta 2 by 2. Okay. So let's discuss some result on ellipse, some result on normal to an ellipse. So first is the line Lx plus my plus n is equal to 0 is normal to an ellipse x square by a square plus y square by b square is equal to 1 if a square by L square plus b square by m square is equal to a square minus b square whole square by n square. So this is the condition for a line Lx plus my plus n is equal to 0 to the normal to the ellipse. Okay. Next, at most we can draw four normals from a point to an ellipse. So if there is given a point, so then we can draw four normals from that point to the ellipse. Okay. Next, if the line in the form of slope intercept form y is equal to mx plus c is normal to the ellipse, then the condition is c square is equal to m square into a square minus b square whole square by a square plus b square into m square. Okay. So this is condition for y is equal to mx plus c is normal to the ellipse. Okay. Next is co-normal points. So what is co-normal points? So first thing, this co-normal points are lies on the ellipse. Okay. So the points on the ellipse are called co-normal points. If we draw the normal at these points, at this co-normal point, then all normal is passes through a given point. Okay. So these points are called co-normal point. So first thing, co-normal points are lie on a ellipse. Okay. And if the points are co-normal points, the condition to be co-normal points is that when we draw normal at this point, then all normal are passes through a given point. Okay. Next is tangent at the end of a lattice rectum in a first quadrant is, so if we draw a tangent at the end of a lattice rectum, in particular in the first quadrant, then it is given by ex by a plus root under 1 minus e square by b, y is equal to 1, or it can be written as ex plus y is equal to a. And normal at this point at the end of lattice rectum in first quadrant is given by ax by e minus by by root under 1 minus e square is equal to a square minus b square, or it can be written as x minus ye is equal to ae cube. Okay. Now, auxiliary circle. So, as you can see the figure of auxiliary circle. So, how we can define the auxiliary circle? So, auxiliary circle is a circle whose diameter is major axis. So, a circle described on the major axis of an ellipse as diameter is called an auxiliary circle. It means we have an ellipse x square by a square plus y square by b square is equal to 1. And as the major axis, length of major axis AA dash, and that is 2a. Clear? So when we consider this AA dash as diameter and draw a circle by using this, then we get a auxiliary circle. Okay, so this is a circle with diameter 2a, it means with radius a, and a center is the origin. So equation of auxiliary circle, that is a circle with diameter with radius a with center at origin, that is given by x square plus y square is equal to a square. Okay, so this is the figure of ellipse with, we draw a circle by taking the major axis as diameter, then that circle is auxiliary circle. Clear? So outer curve, that is outer circle, is your auxiliary circle, and inside there is a oval shape, and that is your ellipse. Okay. Next point is eccentric angle of a point. So we define eccentric angle for a point. Okay. So let P be any point on a ellipse. So we have ellipse x square by a square plus y square by b square is equal to 1, and we define eccentric angle for a point P. Okay, so see the figure. There is a point P on an ellipse. Now draw PN perpendicular from P on the major axis. So what is the construction? We draw P. We draw a perpendicular PN to the major axis. Okay, and then produce this length NP to meet the auxiliary circle in Q. Okay, so we have an ellipse, that equation is x square by a square plus y square by b square is equal to 1. Then we draw a circle by taking the major axis as diameter, then we get an auxiliary circle. Okay, now to find an eccentric angle for a point P that is lies on an ellipse, at first we draw a perpendicular to the major axis, that is Pn, and then we produce that length NP that is meet at a point Q in the auxiliary circle. Okay, and then we get an angle NOQ, and that angle is your eccentric angle of the point P on the ellipse. Okay, so how we get this eccentric angle? First, we take a point on an ellipse, then we draw perpendicular to the major axis, that is Pn, then we reproduce that length Pn to meet the auxiliary circle, that is meet at Q. Then we get an angle NOQ, and that angle is called eccentric angle of a point P on the ellipse. Clear? So the coordinate of Q and P. So now we can write the coordinate of points on ellipse Q and P by using the eccentric angle. So if theta is the eccentric angle, then coordinate of Q and P are a cos theta, a sin theta, and a cos theta, b sin theta. Okay. There is some result on eccentric angle. So first result is eccentric angle of the extremities of latus rectum of the ellipse x square by a square plus y square by b square is equal to 1 r tan inverse plus minus b by ae. Okay. So if we find the eccentric angles of the extremities of latus rectum, so we find the eccentric angle for the end point of latus rectum, then the angle between the eccentric angle of extremities of latus rectum of the ellipse is given by tan inverse plus minus b by ae. Okay. Next is, let's suppose we have a circle and that cut an ellipse. So it can be cut in 4 points, that is can be real or imaginary. Then if we find the eccentric angle for all these 4 points, then sum of the eccentric angles of these 4 concyclic points, as all these points lies on a circle, so or on the ellipse, so this is even multiple of pi. Okay. Next point, when we find the eccentric angles of the co-normal points, then the sum of the eccentric angle of the co-normal points on the ellipse x square by a square plus y square by b square is equal to 1 is odd multiple of pi. Okay, so these are the result on eccentric angle. Next is diameter and conjugate diameter. Okay, so what is diameter? So let's suppose we have a ellipse. Okay, then the locus of midpoint of system of parallel chord. So we draw a parallel chords. Okay, we take a chord and we take collect all the chord that is parallel to that chord. So we get a system of parallel chord. Okay, and when we take the midpoint, when you take the locus of the midpoint of all this parallel chord, that locus is a line and that line is diameter. Okay, that means if we have a system of chords which all have the same slope and we take the locus of the midpoint of all chords that lies on this system, then that locus is called diameter. Okay, if the line y is equal to mx plus c represent a system of parallel chord of an ellipse x square by a square plus y square by b square is equal to 1. So as you can see, the line is y is equal to mx plus c. So for all the line, the slope is m. Okay, so these all lines are parallel chord to the ellipse, and when we take the midpoint, when you take the locus of the midpoint, that is your diameter. And the equation of diameter in this case, when the parallel chords are given by y is equal to mx plus c, is given by y is equal to minus b square by a square mx. Okay. Next thing is conjugate diameter. So how we can define conjugate diameter? So if there is two diameter, then these two diameter are called conjugate diameter when each bisect all chords parallel to the other. So let's suppose we have two diameter d1 and d2, then we call d1 and d2 are conjugate diameter when if we take d1 and all chords that is parallel to d1, then d2 is conjugate diameter to d1 if d2 bisect all chords that is parallel to d1. And in similar way, if we take d2 and then we draw all chords that is parallel to d2, then d1 is conjugate to d2 if d1 bisect all the chords that is parallel to d2. Clear? So this is the definition of conjugate diameter. So if y is equal to mx and y is equal to m1x be two conjugate diameter of an ellipse, then it satisfies a condition that the product of the slope m into m1 is equal to minus b square by a square. So if there is two conjugate diameter and the equation of the diameter are y is equal to mx and y is equal to m1x, then when we multiply the slope of the diameters m into m1, we get minus b square by a square. Okay. Now result on conjugate diameter. So first, the area of parallelogram formed by the tangent and the ends of the conjugate diameter. So we have a conjugate diameter and we draw tangents at the ends of the conjugate diameter. Then we form a parallelogram and the area of this parallelogram is given by, and that is constant. So area is always constant when we draw, when that parallelogram is formed by the tangent at the end of conjugate diameter, and that is given by product of the axis. Okay. So we have conjugate diameter, then we draw tangent at the end of the conjugate diameter, then this form a parallelogram and the area of this parallelogram is always constant and that is given by product of the axis. Okay. Next is the sum of the square of any two conjugate semi diameter of an ellipse is constant. So if we take two conjugate semi diameter, then we take the square of the length of this two semi diameter and we take the sum of this two semi diameter, then we get a constant, and that is equal to the sum of the square of semi axis of the ellipse. So semi axis means a and b, and sum of a square, that is a square plus b square. So if CP and CD are the conjugate semi diameter, the length of this conjugate semi diameter, then square, then sum of the square, that means CP square plus CD square is equal to the sum of the square of the semi axis. It means it is equal to a square plus b square. Okay. Next is the product of the focal distance of a point on an ellipse is equal to the square of semi diameter That means the product of the focal distance of a point. We have a point on an ellipse and we take the distance from the focus, that is focal distance. So the product of focal distance of point on an ellipse, there is two focus, we get two focus distance. Let's suppose P is a point on ellipse, then we get PS and PS1 as a focal distance is equal to the square of the semi diameter. So this product is equal to the square of semi diameter, which is conjugate to the diameter through the point. Okay, so when we draw a conjugate a diameter to the point P, okay, so the product of focal distance SP and S1P is equal to square of semi diameter, and that semi diameter is conjugate to the diameter, that is through the point PXY. Okay, some important points. First one is the eccentric angle. So eccentric angle of the ends of a pair of conjugate diameter of an ellipse is differ by a right angle. Okay, so when we find the eccentric angle for pair of conjugate diameter, then these angles are differ by right angle. Okay, and when we draw the tangent at the end of pair of conjugate diameter of an ellipse, then this form a parallelogram. Okay, now what is conjugate point? So let's suppose there's 2 point P and Q, then P and Q are called conjugate point with respect to the ellipse if the polar of P passes through Q, and in a similar way polar of Q passes through P. So P and Q are the conjugate points if we draw the polar of P, then Q is passes through the polar of P and the polar of Q passes through P. And conjugate lines, so in a similar way two lines are called conjugate lines with respect to an ellipse if each passes through the pole of the pole. Okay, so what is pole and polar? So let's suppose we have a point P that can be lies inside the ellipse or can be outside the ellipse. Okay, so let's suppose we have a point P, and then the locus of point of intersection of tangent to the ellipse at the point where second row through P intersect the ellipse is called polar. So we have a point P and then we draw a second from that point P that cuts the ellipse at 2 point. Okay, and when we draw tangent at that 2 point, okay, and where they intersect, the point of intersection of these 2 points, so the locus of that point of intersection is called polar. Okay, and that point P is called pole for the polar. Okay, and the polar of one point x1 comma y1 with respect to an ellipse x square by a square plus y square by b square is equal to 1 is given by x into x1 by a square plus y into y1 by b square is equal to 1. So let's suppose we have point x1 y1, so this point is called pole. It can be lies inside or outside the ellipse when we draw the second, that is passes through point x1 y1 and that cuts the ellipse at 2 point, let's suppose Q and R. Then we draw the tangent at a point Q and at a point R where they intersect, the point of intersection of this two tangent, and we take the locus of that point of intersection. That locus is again a straight line and that is your polar for the point x1 y1, and that is given by x into x1 by a square plus y into y1 by b square is equal to 1. Okay, so just wait for a moment. Okay. So now we'll practice some question on ellipse. So first question, the equation x square by 8 minus a plus y square by a minus 2 is equal to 1 will represent an ellipse if option A belongs from 1 to 4 and A lies from minus infinity to 2 union 8 to infinity, and C, A belongs to 2 to 8 open interval 2 to 8, and option D, none of this. Okay, so try this question. So what is standard form of ellipse? X square by a square plus y square by b square is equal to 1. So to be an ellipse, what is the condition between a square and b square? So just recall that condition and solve this. The condition is a square and b square must be positive. Clear? And a square should be not equal to b square. So use this two condition to find the value of a, the set of values of a. Anyone? Which option is correct? Okay, let's solve. Correct answer is D, that is none of these. Formula that we use. First, the general equation of an ellipse is x square by a square plus y square by b square is equal to 1, where a is not equal to b. This is the first condition. So, the equation x square by 8 minus a plus y square by a minus 2 is equal to 1 will represent an ellipse if first 8 minus a is greater than 0, a minus t is greater than 0, the first condition, and second 8 minus a is not equal to a minus 2. So from first condition 8 minus a greater than 0 we get minus a is greater than minus 8, that means a is less than 8. And from second condition a minus 2 greater than 0 we get a is greater than 2, that means a lies between 2 and 8. But when we solve the third condition, 8 minus a is not equal to a minus 2, we get a is not equal to 5. So we get that a lies between 2 and 8 and a is not equal to 5. That means a lies from open interval 2 to 8 where we remove the point 5. Okay, so correct answer is this, open interval 2 to 8 minus 5. So answer is none of these. Okay. Second question. So, equation of ellipse whose minor axis is equal to the distance between the foci and whose latus rectum is 10, okay, is given by. So, take origin as center and major axis along x-axis. So, we have to find equation of a ellipse, and there is information about that ellipse is the minor whose minor axis is equal to the distance between the foci and whose latus rectum is 10. So what is the length of minor axis? Recall. And how we can find the distance between the focus? There is two focus. And what is the distance between the focus? How we give this? So use that equation, and also you use the equation length of latus rectum, that is 10, and then find the equation of ellipse. Which option is correct? Option A is 2x square plus y square is equal to 100. Option B is x square plus 2y square is equal to 100. Option C, 2x square plus y square is equal to 50. And option D, none of this. So try this question. Anyone? What is the equation of length of latus rectum? How we can find the length of latus rectum? Formula is, and the distance between two focus is given by, what is the formula? And also length of minor axis is given by, if you know this three formula, then you can easily calculate the equation of this ellipse. Okay, let's solve. Correct answer is option B, that is x square plus 2y square is equal to 100. So equation of ellipse is x square by a square plus y square by b square is equal to 1. Then there is a relation, that is b square is equal to a square 1 minus e square. Okay, relation between a, b and eccentricity. Okay. Now distance between the forces given by of an ellipse is 2ae. Okay. So first thing is given that minor axis, the length of minor axis is equal to the distance between the foci. So 2b is equal to 2ae because the length of minor axis is 2b. So we get 2b is equal to 2ae, and from here we get b is equal to ae. And when we substitute into the relation b square is equal to a square 1 minus e square, in place of b we write ae. So we get a square into e square is equal to a square 1 minus e square. And when we solve this, we get the value of e square is equal to 1 by 2. We just solve this. Okay. So now we have e square is equal to 1 by 2. Next thing, it is given that whose latus rectum is 10, and latus rectum is given by 2b square by a. So 2b square by a is 10. Okay. So from here we get b square is equal to 5a. So now we again use the relation b square is equal to a square into 1 minus e square. Now we have value of b square, that is 5a, and value of e square, that is 1 by 2. So substitute this value, we get a square into 1 minus 1 by 2 is equal to 5a. So we get a square by 2 is equal to 5a. That means a square is equal to 10a. So we get a is equal to 10. And when we have the value of a, we can calculate a square, that is 100. And by using the relation 2b square by a is equal to 10, we can also calculate the value of b square, that is 50. So b square is 50 and a square is 100. So equation of ellipse is x square by a square plus y square by b square is equal to 1. That is x square by 100 plus y square by 50 is equal to 1. So we can write it as x square plus 2y square is equal to 100. Clear? Next question. Let AB be a rod of length 4 unit. Okay. What is the length of AB? That is 4 unit. With A on x and B on y axis. That is the length. First, one end of this rod is lie on x axis, that is A, and one end of the rod is lie on B axis, on y axis. Okay. Rod AB slides on axis. Okay. So now rod AB slides. If point P divide AB in the ratio 1 is to 2, and there is a point P that is lies on the line segment AB that divide this rod in the ratio 1 is to 2. So the locus of P is an ellipse. So when the rod is slide and the P divide AB in the ratio 1 is to 2, so when you take the locus of the point P, that is an ellipse. Okay. So we have to find the eccentricity of this ellipse. Okay. And given options are option A 3 by 4, option B root 3 by 2, option C 2 by 3, and option D none. So try this question. Anyone? Which answer is correct? Which option is correct? Okay, let's solve. Correct answer is option B, that is root 3 by 2. So how we get this? The first formula that we use is if the point P divide the line segment AB, coordinate of A is x1 y1 and B is x2 y2, in the ratio m is to n, then coordinate of P is given by section formula is P is equal to mx2 plus nx1 by m plus n and my2 plus ny1 by m plus n. Okay. And there is a relation with A, B and E, that is B square is equal to A square into 1 minus E square for any ellipse, x square by A square plus y square by B square is equal to 1. Okay, so let's solve. Now, there is a rod AB with a length 4 unit and A is lies on x axis. So let the point is A comma 0 and point B is 0 comma B, that is lies on y axis. Okay. Now P divide this line rod AB in ratio 1 is to 2. So by using section formula, we get H is equal to 2A by 3 and K is equal to B by 3. We just apply the formula of section formula. So there is a rod as in this figure. A is one end point of rod that is lies on x-axis, that is A comma 0, and B is another point that is lies on y-axis 0 comma B. And now this point, this rod slides on axis, and let P, there is a P that is point that divide this rod AB into is to 1. And the coordinate of P we get by the section formula, that is 2A by 3 and B by 3. Okay. Now you have to find the locus of P. Okay. So the locus of P is an ellipse. Okay. And then we have to find the eccentricity of this ellipse. Okay. So another information is that AB be a rod of length 4. That means the distance AB is 4. So now we apply the distance formula on the coordinate 0, B and A, 0. So we get A square plus B square, and we substitute the value of A and B that we get from the value of H and K. So we get 9H square by 4 plus 9K square, and that is equal to 16. Okay, that we use the distance formula. Okay, and we use the value that we get by the section the coordinate of H and K, that is H is equal to 2A by 3 and K is equal to B by 3. So A is equal to 3H by 2 and B is equal to 3K. So we just put the value of A and B. So we get 9H square by 4 plus 9K square is equal to 16. Okay, so locus of P, that is an ellipse. So we get x square by 64 by 9 plus y square by 16 by 9 is equal to 1. Okay, we just solve the equation 9h square by 4 plus 9k square is equal to 16. We just write in the form of ellipse, standard form of ellipse. Then we get this. We replace h and k by x and y. So we get x square by 64 by 9 plus y square by 16 by 9 is equal to 1. So now we have value of a square and b square. And there is a relation with eccentricity with a and b. So we use that relation. That relation is b square is equal to a square into 1 minus a square. So substitute the value of b square and a square. We get 16 by 9 is equal to 64 by 9. 1 minus e square. Then solve this equation for e. So we get e square is equal to 3 by 4. That is equal to root 3 by 2. So that is your eccentricity. Okay. Now question number 4. Equation of the ellipse. So we have to find equation of a ellipse. Now what is given? Whose axes are the axes of coordinates. So axes of this ellipse are nothing but axis of coordinates, and which passes through the point minus 3 comma 1. This ellipse is passes through a point minus 3 comma 1 and has eccentricity root under 2 by 5. Okay. Then what is the equation of ellipse? Given options are option A 5x square plus 3y square minus 48 is equal to 0. Option B 3x square plus 5y square minus 15 is equal to 0. Option C 5x square plus 3y square minus 32 is equal to 0. And option D 3x square plus 5y square minus 32 is equal to 0. Okay. So solve this. Okay, let's solve. So correct answer is option D, that is 3x square plus 5y square minus 32 is equal to 0. So the formula that we use, so for an ellipse x square by a square plus y square by b square is equal to 1. Eccentricity is given by a square is equal to 1 minus b square by a square. Okay. So let the equation of ellipse is x square by a square plus y square by b square is equal to 1, where a is greater than b. Now what is given? Whose axes are the axis of coordinate and which passes through point minus 3 comma 1. Okay. And also given that eccentricity is root under 2 by 5. Okay. So as this ellipse passes through minus 3 comma 1, so we can substitute in the place of x is minus 3 and y is 1, then it satisfy the equation. So we get 9 by a square plus 1 by b square is equal to 1. Okay. So name this equation as equation 1. Now we use the second information, that is eccentricity is root under 2 by 5. So we know that eccentricity square is equal to 1 minus b square by a square. So we substitute the value of e, that is root under 2 by 5. So we get e square, that is 2 by 5. So 2 by 5 is equal to 1 minus b square by a square. So from here we get b square by a square is equal to 3 by 5. Okay. Okay. So we can write b square as 3 by 5 into a square. Now substitute the value of b square in the equation 1 that we get when we substitute the point minus 3 comma 1 into the equation of ellipse. So we get 9 by a square plus 5 by 3a square is equal to 1. Now solve this equation for value of a. So we get 27 plus 5 by 3a square is equal to 1. And from here we get the value of a square is 32 by 3. And when we have the value of a square, then we can calculate the value of b square by using the relation b square by a square is equal to 3 by 5. So from there we get b square is equal to 32 by 5. And when we have the value of a square and b square, then we can easily write the equation of that ellipse. So equation of ellipse is 3x square by 32 plus 5y square by 32 is equal to 1. That can be written as 3x square plus 5y square is equal to 32. Okay, clear? Next question. If the angle between the straight line joining foci and the end of minor axis of the ellipse x square by a square plus y square by b square is equal to 1 is 90 degree, then its eccentricity is option 1 by 2, option B 1 by 4, option C 1 by root 2, option D none. So try this question. At first draw the figure according to the question. Foci are given by coordinate is AE comma 0 and minus AE comma 0. For this ellipse, x square by a square plus y square by b square is equal to 1. Okay. And what is end of minor axis? Coordinate of end point of minor axis? That is 0 comma b. Okay. So use this. So correct answer is option C, that is 1 by root 2. Okay. So the first formula for an ellipse x square by a square plus y square by b square is equal to 1. We know that b square is equal to a square into 1 minus e square. Okay. And coordinate of focus of an ellipse is given by, there's two focus, so we get plus minus ae comma 0. First focus is ae comma 0 and second one is minus ae comma 0 when a is greater than b. Okay. So it is given that the angle between the straight line joining focus and the end of minor axis of an ellipse is 90 degree. That is angle when coordinate of focus f1 is ae comma 0, f2 is minus ae comma 0 and b is end of minor axis is 0 comma b. And it is given that the angle f1b f2 is 90 degree, that is pi by 2. Clear? So we have to find the value of eccentricity. Okay. Now as we know the coordinate of point f1, f2 and b, and as the angle is 90 degree, so we can at first we can find the slope by using these coordinates, and we know that when the angle is 90 degree, then slope of these two lines is product of the slope is -1. So we use that property. So what is slope of b f1? As b is 0 comma b and f1 is ae comma 0. So find the slope by using, how we can find the slope when the 2 points are known, y2 minus y1 by x2 minus x1. Then we apply the formula, and as the angle is 90 degree, so the product of slope is -1. So we get minus b by ae into minus b by minus ae is equal to -1. And when we solve this, we get b square is equal to a square into e square. Okay. Now we have the value of b square, that is a square into e square. So used in the relation of b square is equal to a square into 1 minus e square. So from here we get a square into e square is equal to a square into 1 minus e square. A square is cancelled out. We get e square is equal to 1 minus e square. So we get 2e square is equal to 1. So e square is equal to 1 by 2. That means e is 1 by root 2. So eccentricity is 1 by root 2. Okay. Question number 6. The ellipse 4x square plus 9y square is equal to 36 and the straight line y is equal to mx plus c intersect in real points only if options A, that is 9m square less than equal to c square minus 4, option B, 9m square is greater than c square minus 4, option C, 9m square greater than equal to c square minus 4, and option D, none of this. So try this question. What is the condition when two curves intersect at a real point? That means ellipse 4x square plus 9 square 36 and the straight line y is equal to mx plus c intersect in real points. Okay. Okay, let's solve. Correct answer is option C, that is 9m square greater than equal to c square minus 4. Okay. So for a quadratic equation to have real roots, we know that the discriminant is greater than equal to 0. That is b square minus 4ac should be greater than equal to 0 for real roots. Okay. Now, as these two curves are intersecting, so when we solve, we get point of intersection. So 4x square plus 9y square is equal to 36 ellipse and y is equal to mx plus c, that is straight line. So when we solve these two equations, just substitute y is equal to mx plus c in the equation of ellipse. So we get 4x square plus 9 into mx plus c whole square minus 36 is equal to 0. That is 9m square plus 4 into x square plus 18c mx plus 9c minus 36 is equal to 0. This is a quadratic equation. And for real root, b square minus 4ac greater than equal to 0. So what is the value of b? That is 18 centimeter, 18c into m. So we get 18 into c square m square minus 4ac. So we get 4. The value of a is 9m square plus 4. So we get 9m square plus 4. And value of c is 9c square minus 36. So we get 18c square m square minus 4 into 9m square plus 4 into 9c square minus 36. And for real root, it should be greater than equal to 0. Okay. Now simplify this. We get 9m square minus c square plus 4 is greater than equal to 0. And from here we get 9m square is greater than equal to c square minus 4. So this ellipse and the straight line intersect in real points if 9m square is greater than equal to c square minus 4. Okay, clear? So that's all for today. Any doubt? Okay then, thank you.
Hello students, in today's lecture we are going to learn about wave optics, and this is theory part first. This is our disclaimer. So let's see firstly trend analysis of the chapter wave optics in JEE Main examination. So according to last 5 years data, this chapter the overall weightage is 2.30%, or we can say 2 to 3%. Okay, if we talk about yearly question distribution, so we can say in 2024 question asked from diffraction, number of questions 1, and if we talk about the difficulty level, so we can say question was average. Similarly, in 2023 question asked from Young's double slit experiment or diffraction, number of questions 2, one question was average, one question was difficult. In 2022 question asked from interference of light, number of questions 1, and their difficulty level we can say question was average. Similarly, students, in 2021 question again asked from interference of light, waves, and Young's double slit experiment, number of questions 1, and if we talk about their difficulty level, so we can say question was difficult. Okay, in 2020 question asked from diffraction and polarization of light, number of questions 2, and both question was average. Okay, so from this data we can say diffraction, polarization of light, or interference, or Young's double slit experiment are most important concepts for the examination. All right. So in today's lecture we will cover first wave front. After that we will discuss about Huygens principle. Then we will discuss coherent sources. Then we will discuss about interference of light, constructive interference or destructive interference. After that we will talk about conditions for constructive interference, then condition for destructive interference. All right. So these are the topics that we will study in today's lecture. All right, students, clear? Good. So wave optics. So our first concept, Huygens principle. So let's talk about Huygens principle. You know, uh, according to Huygens principle, light is a form of energy, okay, that travels as a wave through a hypothetical medium, and this hypothetical medium is called ether. Okay, ether was considered a medium that is present everywhere, completely transparent, very light, perfectly elastic, and behaves like an ideal fluid. Okay, so these light waves transfer energy from one location to another. Light waves transmit momentum along with energy and travel in space with at a constant speed of 3 into 10 to the power 8 meter per second. Okay. However, when light passes through a material medium, its speed depends on the refractive index of the medium. Okay. Therefore, the speed of light depends on the refractive index of the medium, and the speed varies for different mediums. So from uh, this statement we can say if the medium is changed, then the speed of light will also change. Okay. Next concept is wavefront. Look at here the figure. This is a wavefront. So now let's talk about the wavefront. So listen carefully. When we drop a small stone into a calm pool or calm pond, okay, as shown here, look at here. So assume initially the water is completely still. When you drop a small stone at this central point, the place where the stone fell is called the point of impact. Okay, and from this point of impact, waves spread out in all directions. So as shown in the figure, so the point of impact is this one. So when we dropped a small stone at this point, the waves spread out in all directions. Okay, and every point on this surface, every point on this surface starts to oscillate with time. If a photograph of the surface is taken at any given time, circular rings will be visible where the disturbance is maximum. Okay, so every point on the surface, like this point, okay, this point, all these oscillate with time. Okay, and if we look at a photograph of this surface at any given time, so circular rings will be visible. Okay, clear? Clearly, all points that are on this same circle uh, are oscillating in same phase. Why? Because they are at same distance from the source, or we can say from the point of impact. So we can say that this is the point of impact. Okay, this is the point of impact, or else this is the source from which waves spreading in all directions. Okay, so the locus of all such points that oscillate in same phase is called wavefront. All right, and here we will discuss different types of wavefront. Clear? So, and if we talk about the speed, so we can say the speed at which the wavefront moves outwards from the source is called speed of the wave. Okay, so now we will discuss different types of wavefronts, like spherical wavefront, plane wavefront. So first we will learn spherical wavefront. So if we have a point source that emits waves uniformly in all directions, okay, then the locus of all those points which have the same amplitude and vibrate in the same phase are spheres. Okay, and this is called the spherical wavefront. So assume this point, a point source. Okay, when waves spread from this point source, then in that case the shape of the wavefront should be spherical, or we can say that spherical wavefront. Why? Because from this point of impact, waves spreading in all directions. Okay, That's why we called spherical wavefront. Now we have diverging wavefront. Okay, we can divide spherical wavefront into two types. First, we have a diverging wavefront. Okay, so if we talk about diverging wavefront, so we can say it diverges from point of impact. Okay, so assume this point O. Assume this point. This is a point source, and in a diverging spherical wavefront, spread outwards. Look at here. This arrow, which indicates in outward direction from O. So we can say this is spreading in outward direction. Okay. So the wavefront spreads out. So in outward direction, just as this wavefront is spreading in outward direction. Okay. The second is converging spherical wavefront. Let's see. A spherical converging wavefront is a wavefront that is shaped like a sphere, okay, and moves inward towards a focal point. Look at here. Moves towards inward. Okay. Rather than outward from a source. Next, we have a plane wavefront. So if we talk about plane wavefront, so we can say when the source is very far away. Okay, assume the source is at infinity. Okay, very far. In that case, students, a small part of this sphere can be considered as a plane. Okay, and what we have is called a plane wavefront. Okay, so this is the representation. This is the representation of plane wavefront. Okay, when the source is at infinity. So here we can say there are two types of wavefronts: spherical wavefront when the source is a point source, and second plane wavefront when the source is very far away. Okay, therefore this is a plane wavefront. All right. Now we will understand Huygens principle. Clear? So according to Huygens principle, every point, listen carefully, every point on a spherical wavefront acts as a source of secondary disturbance. Okay. So assume here, assume this is a wavefront. Okay. This is the wavefront. What is visible on this graph is the first wavefront. Okay. So every point, for example, this point, this point, this point, this point, this point, or this point, every point uh, on this wavefront is a secondary disturbance. All right. And the wavelets that emerge from these secondary disturbances, we call them secondary wavelets. So these wavelets spread out in all directions from all these points. Okay. So in this manner, uh, here these are secondary wavelets, and if we draw a common tangent, so we can say which touches the all these points. Look at here, common tangents like this, like this, like this. Okay, which touches all these points. Then this collection of tangent points is the new wavefront. Okay, the second wavefront. Similarly, waves spread out from the point of impact, and this is an example of a spherical wavefront. Similarly, in a linear wavefront, okay, as well. So assume this is a linear source, okay, this is a linear source. In that case, uh, every point on the wavefront is a secondary disturbance according to Huygens principle, and this point is also a secondary disturbance. So a common tangent, this one, touches all uh, the points. So we obtain a new wavefront after some time. So this is a spherical wavefront and this is a linear wavefront. Okay, spherical or linear. Clear? Any doubt here? Yes or no? Now we will discuss coherent sources. So two light sources are called coherent when both emit light of exactly the same frequency or wavelength and originating phase difference between them is either zero or remains constant at any point with respect to time. Okay, so suppose there are two light sources, okay, both sodium lamps. We call one source of light S1 and one source of light S2. Okay, when light emanating from both sources meets at a single point, are these two sources coherent? Think about it. Yes or no? No, because they cannot maintain a constant phase difference between them. And when light travels from one point to another, so the condition for coherent sources is that light source will only be called coherent when they emit light of exactly the same frequency and the phase difference remains the same at any point. Okay, so here the frequency is also the same and the wavelength is also the same, but if the phase difference is not constant, then they will not be called coherent source. Okay, any doubt? Yes or no? Now we will discuss interference of light. So what is interference of light? Think about it. Interference of light is a phenomena in which the energy of lights gets redistributed in space. When two light sources, or we can say when two light waves which have the same frequency or wavelength and are emitted from two coherent sources, travel in the same direction and superimpose on each other, then this phenomena is called interference of light. Okay, so there is a condition, and that condition is what? Light should be, the waveform of light should be superimposed on each other. In that case, this phenomena known as interference of light. Okay, so let to find out the amplitude of the resultant wave. So let A1 and A2 be the amplitudes of two light waves. Okay, both having the same frequency, and phi is the phase difference between them. Okay, Look at here. This phi is the phase difference. That is, phi is the phase difference between two waves. Then the formula for amplitude of resultant wave is given as AR equal to under root A1 square plus A2 square plus 2A1 A2 cos phi. Okay. Here AR represents the amplitude of the resultant wave, which is obtained from this formula. Okay. And this formula is this is the formula for the resultant wave and very important for the exam. Okay. And if we look in terms of intensity, the resultant intensity IR is equal to I1 plus I2 plus 2 into under root I1 I2 cos phi. Okay. So that is this is the formula for the resultant intensity. So from this relation, and it is clear that intensity is directly proportional to the square of the amplitude. Okay. So this is the interference of light. So both formula for resultant amplitude and intensity of light will be for will important for the exam. Okay. Now next is condition for constructive interference. We know two types of interference: constructive interference and destructive interference. If we talk about constructive interference, so in case of constructive interference, uh, if at any point in space the phase difference phi between two waves is 0 degree, phi is the symbol for phase difference. Okay. Or we can say phi equal to 2 and pi, or path difference between two waves is delta equal to 0. Alright. Here, so in case of constructive interference, uh, when two waves, look at here, when two waves, first and second, when two waves add up their amplitude and looks like enforcement. Okay. When two waves add up and form a new wave, and their amplitude will be equal or greater than as compared to previous two waves. So this is for this is known as constructive interference. So then the resultant amplitude AR, A1 plus A2, or this resultant amplitude, clear, and intensity IR equal to I1 plus I2 plus 2 into under root I1 I2 is maximum. So there is a resultant intensity and resultant amplitude in case of constructive interference. So there is a only reinforcement of waves. First wave, this one first wave and second wave. So when both add up and form a new wave, and the amplitude of this wave is greater or equal to this wave and this wave. So this is the constructive interference. So interference is called constructive interference. Okay. Here we know resultant amplitude is greater than the individual wave's amplitude. Okay. Second is destructive interference. So if we talk about destructive interference, so this is the opposite of constructive interference. If at any point the phase difference phi between two waves is equal to 2 and minus 1 pi, or we can say path difference delta equal to 2 and minus 1 into lambda by 2. So at such points the resultant amplitude AR equal to A1 minus A2, and the resultant intensity IR equal to I1 plus I2 minus 2 into I1 under root I1 into I2 is minimum, leading to a destructive interference. So here there are two cases. First, constructive interference, and the second, destructive interference. In case of constructive interference, resultant amplitude A1 plus A2 and intensity I1 plus I2 I1, we can say I1 plus I2 and square root of plus of square root of I1 I2. Okay, and in case of destructive interference, I1 resultant intensity I1 plus I2 minus 2 into I1 I2. Okay, so from this diagram, this figure, it is clear that the suppose there are two waves. This is the first wave and this is the second wave. Okay, when both waves superimpose at a same point, then they are opposite, therefore the resultant wave cancels out. Okay, and so this is the condition for destructive interference. And both formula for the formulas for both the cases, constructive interference and destructive interference, are important for the exam. Okay everyone, thank you for your attention. Now students, we will solve some practice questions based on wave optics. Okay, so are you ready for practice questions? Yes or no? All right, please wait 2 minutes. Hello students, now we will solve some practice questions based on wave optics, and this is part first. This is our disclaimer. So here we will solve some practice questions based on uh, wave optics. Okay. So our first question, the wavefront of a distant source of light is of shape what? So in this question, it is asked what the shape of the wavefront will be when the source is distant, meaning the source is very far away. Okay. So given options, option A, shape will be spherical, option B, cylindrical, option C, elliptical, and option D, plane. So students, in this question, you have to find out the shape of the wavefront. Okay, and please solve this question and try to find the correct option. This is a very simple question. Okay, so which one is correct? Please tell me. Yes, you have some time. Please solve this question. Which one is correct? Please solve this question. You have some time and find out the shape of the wavefront. Which one is correct? A. All right. So the correct option will be option D. Okay. So listen carefully. In this question, question says that the wavefront uh, from a distant source of light is considered. Okay. Here. All right. So this is because at a great distance from the source, the spherical wavefronts have a very large radius or large radius of curvature. Okay, and a small portion of this large sphere can be approximated as a plane. Okay, looks like this. So, we can say the shape of the wavefront should be plane. Okay, clear? Next question. In a Young's double slit experiment, two coherent sources are placed 0.90 mm apart and the fringes are observed 1 meter away. If it produces the second dark fringe at a distance of 1 mm from the central fringe, the wavelength of the monochromatic light used will be what? Okay, so the question asked is about Young's double slit experiment. Okay, we know in Young's double slit experiment, two coherent sources are placed. Okay, so here sources are placed uh, of 0.9 mm, and this is the distance between the two coherent sources, and fringes are being observed at a distance of 1 meter. If the second dark fringe is formed at a distance of 1 mm from the central fringe, this means that the second dark fringe is 1 meter away from the central fringe. Okay, so when the screen is 1 meter away from the central fringe, okay, so now the question is asking what the wavelength of the monochromatic light will be. Given options: option A 60 into 10 to the power minus 4 centimeter, option B 10 into 10 to the power 10 into 10 to the power minus 4 centimeter, option C 10 into 10 to the power minus 5 centimeter, and option D 6 into 10 to the power minus 5 centimeter. So which option is correct? You have to find out the correct one. Please solve this question and find out the correct option. Okay, you have some time. Please solve. Which one is correct? A, B, C or D? You have to find out the wavelength of the monochromatic light. Okay, which one is correct? A, B, C or D? The correct option will be option D, 6 into 10 to the power minus 5 centimeter. Okay, so let's see the solution. In Young's double slit experiment, we will use the formula for the position of dark fringes. All right. So in Young's double slit experiment, the formula for the position of nth dark fringes is x is equal to 2n minus 1 into lambda d divided by 2d. So here uh, lambda equal to 2xd divided by 2n minus 1 into d when we rearrange this formula. Okay. Now we will put the given parameters in this expression. So after putting them, we get the equation lambda equal to 2 into 10 to the power minus 3 into 0.9 into 10 to the power minus 3 divided by 2 into 2 minus 1 into 1. Alright. So lambda equal to 6 into 10 to the power minus 5 centimeter. So wavelength of the monochromatic light used is 6 into 10 to the power minus 5 centimeter. Alright. Next question. In Young's double slit experiment, the two slits acts as a coherent sources of waves of equal amplitude A and wavelength lambda. Okay. So in another experiment with the same arrangement of two slits are made to act as a incoherent sources of waves of same amplitude and wavelength. Alright. So if the intensity at the middle point of the screen in the first case is I1 and in the second case is I2. Okay. Then the ratio of I1 upon I2 is what? So here you have to find out the ratio of I1 and I2. Alright. Okay. Let's understand the question. So the question states that in Young's double slit experiment, two slits acts as a coherent sources, okay, whose waves have equal amplitude and wavelength lambda. In another experiment, student, with the same arrangement, both slits are made to act as a incoherent sources, but the amplitude and wavelength of this wave are still the same. Okay, so here we can say there are two situations. In the first situation, the sources are coherent, and then in the second situation, the sources are incoherent. Okay, so if the intensity at the central point of the screen is I1 in the first case and I2 in the second case, then what will be the ratio of I1 divided by I2? Okay, given options: option A 4, option B 2, option C 1, and option D 0.5. So which one is correct? Please solve. This is typo error. Okay, this one, typo error. So here you have to find out the correct one. A, B, C, D. There is a 4 option. Please find the correct one. You have some time. Please solve. Which one is correct? You solving? Which one is correct? A, B, C, or D? So the correct option will be option B. Let's see the solution. So in Young's double slit experiment, when sources are coherent, okay, the intensity at any point is given by the superposition of two waves, okay, which is I1 equal to 4 I naught cos square 5 by 2, which is equal to 4 I naught, and this is for central maxima. However, when sources are incoherent, okay, the intensity simply add up. So I2 equal to what? I2 equal to I naught plus I naught, which is equal to 2 I naught. Okay, intensity of both sources is same. So here net intensity at the center will be 2 I naught. This means that in these two cases, the intensity ratio will be 2. Yes or no? So I1 upon I2 equal to 2. Okay. So B option is correct. All right. Next question. A mixture of light consisting of wavelength 590 nm means nanometer, and an unknown wavelength uh, illuminates the Young's double slit and gives rise to two overlapping interference patterns on the screen. The central maximum of both lights coincide. Further, it is observed that the third bright fringe of known light coincides with the fourth bright fringe of the unknown light. Okay, so from this data, the wavelength of the unknown light is what? So in this question says that a mixture of light in which one wavelength is 590 nanometer and the other is an unknown wavelength. Okay, uh, illuminates Young's double slit experiment and forms overlapping interference patterns on the screen. The central maximum of both lights coincide. and if it is further observed that the third bright fringe of the known light coincides with the fourth bright fringe of the unknown light. Okay, so from this data we need to find the wavelength of the unknown light. Okay, so in this question it is asked what the wavelength of the unknown light. Okay, so given options: option A 885.0 nanometer, option B 42.5 nanometer, option C 776.8 nanometer, option D 393.4 nanometer. So which option is correct? Option A, option B, option C, or option D? Please find out the correct option. You have some time. Okay, please solve this question, everyone. This is a very simple question. All right, please solve. Which one is correct? A, B, C, or D? Okay, anyone? Do you solving? Varsha, Karthik, VK? Yes. Which one is correct? Okay, please solve this question. So the correct option will be option B. Okay, let's see the solution. So we know in Young's double slit experiment, the position of the nth bright fringe from the central maxima is given by the formula. So formula will be xn equal to n into lambda into d divided by small d, where xn is the distance of the nth bright fringe from the central maximum. Lambda is the wavelength of light, and capital D is the distance between the slits and the screen, and D is the distance between two slits. Okay. Now it is given in the question that third bright fringe of no light coincides with the fourth bright fringe of the unknown light. Okay, so what will be the next step to solve this question from this information? So from this information we can say uh, here we will use the formula to calculate the, here it is given that third bright fringe, okay, of known light coincides with the fourth bright fringe of the unknown light. Okay, so we can say lambda 1 be the known wavelength and lambda 2 be the unknown wavelength. Okay, lambda 1 be the known wavelength and lambda 2 be the unknown wavelength. So according to this question, third fringe of the known wavelength coincides with the fourth fringe of the unknown wavelength. So we have equation that is x3 known is equal to x4 unknown. All right. So now we will use the formula 3 lambda 1 d divided by small d. This is the nth bright fringe from the central maxima in Young's double slit experiment. And for x4 unknown, it will be 4 lambda 2 capital D divided by small d. Okay, yes or no? So when we rearrange it, it will be what? When we rearrange it, it will be lambda 2 equal to 3 lambda 1 divided by 4, which is equal to 3 by 4 into 590 into 590. And when we solving this calculation, you will get 492 442.5 nanometer. Okay, so this means unknown wavelength is 442.5 nanometer. All right, this one is the correct. Next question. Two current point sources S1 and S2, and the separation, uh, they are separated by a small distance, small d, as shown here. Okay, the fringes obtained on the screen, this is the screen, will be what? And the distance from S1 and screen is capital D. Okay, this question is asked in JEE Main 2013. Question asked about the uh, fringes obtained on the screen will be what? Given options: option A parabola, option B straight lines, option C semicircle, and option D uh, concentric circles. So which option is correct? Please solve this question, you have some time. Okay, please solve. Which one is correct? Please solve. Yeah, please solve this question. Karthik, Varsha, VK, resolving. Yes or no? Four options are given and you have to find out the correct one. All right. S1 and S2 are sources. Okay. No, 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 no. Listen carefully. Capital D is the distance between sources and source S1 and screen. Okay. Capital D is the distance between source S1 and D. Whereas small d is the distance between the sources. Okay. This is the separation. Small d tells us about the separation between the sources S1 and S2. Okay. And you have to find out the fringes obtained on the screen will be what? Parabola, straight lines, semicircle, or concentric. Now clear? All right, please solve. Yes, anyone? Give me the correct answer. Which one is correct? All right. So the correct option will be option C, concentric circles. All right. Let's see the solution. So it is given case a path difference for a point on the screen is constant for a given circle centered on the axis connecting the two sources. This means that the interference fringes formed on the screen will be concentric like this. Okay, like this. So D option will be correct. Thank you for your attention. Now students, we will solve DPP based on wave optics. Okay, so please wait 2 minutes. So let's discuss the DPP based on wave optics part 1. All right. So here first question is path difference between two wave fronts emitted from coherent sources is 2.1 micrometer. All right. And phase difference between the wave fronts at that point is 7.692 pi. Wavelength of light emitted by the source will be what? So students, here we have to find out the wavelength of the light. Okay. So you know the formula of phase difference? Yes or no? So delta phi is equal to what? Delta phi is equal to 2 pi upon lambda into delta x. Yes or no? So just put the given terms here. We know delta x is what? Delta x is equal to 2.1. 2.1, this is given 2.1 micrometer. All right. Whereas we know micrometer means 10 to the power. Yes, correct. 10 to the power minus 6. So we can write this delta x is equal to 2.1 into 10 to the power minus 6 meter. All right, this one. Okay, and we know the value of pi, that is 3.14, and we know the value of lambda, that is given here. Yes or no? No. This is we have to find out. Okay. So this formula we will arrange in terms of wavelength. All right. So let's see. lambda will be like this. Now we will change the color. Green. Your favorite color is green. So, okay. Green. Okay. So, lambda will be what? Lambda will be a lambda equal to, yes, it will be 2 pi divided by delta phi. Yes, yes, you are correct. Your option is correct. Delta phi into delta x. Yes or no? So, just put the values. So, lambda equal to 2 pi means 2 into 3.14. Alright. Divided by delta phi. That is what? Delta phi is given. Yes or no? Yes or no? Yes, it is given. This is 7.692 pi. Okay. So we will neglect here pi because it is easier to calculate. 2 into, look at here, 2 into pi divided by value of delta phi. It will be 7.692 pi. Okay. Into delta x. And we know the value of delta x, that is 2.1 into 10 to the power minus 6 meter. Alright. Now when we solve this term, okay, just perform the calculation. You will be get lambda equal to something. And what is that? Anyone? What is that? Yes, please answer. Yes or no? When we performing calculation, you will be get the lambda. Okay. So lambda is, it will be like lambda equal to 2 into, we can say 2 into 2.1, pi cancel out. Okay. 2 into 2.1 into 10 to the power minus 6 meter and divided by 7.69. Yes or no? 692. Okay, this is 692. So it will be lambda equal to 4.2. Yes, correct. 4.2 into 10 to the power minus 6 meter divided by, yes, 7.692. Okay. And when we is performing the calculation in easier way, so it will be 5460 angstrom. Alright. So this is our correct answer. Clear? This is our correct answer. This one. Okay. Yes or no? Any doubt? Alright. Very good. Next question. So let's see next question. Second question here. Two coherent sources, two coherent light beam of intensity I and 4I, okay, are superimposed. If the maximum and minimum possible intensities in the resulting beam are I max and I minimum, then I max minus I minimum is equal to Ni. Find the value of N. So students, here you have to find out the value of N. Okay. Here you have to find out the value of N. Please solve this question. N. Alright. So first we will find out the I max. Okay. I max means I maximum. Then we will find out the I minimum. I minimum. Okay. Yes or no? So firstly we will find the I max. Then I minimum. So do you solving? I minimum. Okay, then we will find out the I minimum, then I maximum. Okay, please solve. So we know the formula of intensity. I max is what? I max is equal to, it will be under root this one, under root I1, and I1 is what? I here, plus under root I2, that is here what? That is 4 times of I. Okay, and whole square. So when we solving this, you will be get what? You will be get 3 into under root I square. This 3 into under root I whole square. Yes or no? So it will be what? 9I. 9I. Alright. This is 4I, not T. Clear? So when we solving this, it will be I plus, it will be, we can say 4I plus what? Plus 2 under root I1 I2 cos phi. Okay. So when we putting the values, you will be get I max is equal to 9I. Alright. I max will be 9I. This one. Similarly, we will find the I minimum. Okay. So when we solving I minimum, so it will be comes out I. Okay. So here quotient find out the I max minus I minimum. It means what? It means 9I minus 9I minus I. So it will be 8I. So when we comparing this term, this one, so you will be get what? You will be get this one n I. Okay. So what is the value of n? N should be 8. Clear? Yes or no? Any doubt? All right. Let's see next question. So in this question, two beams of light having intensities I and 4I. Okay. Interfere to produce a fringe pattern on a screen. The phase difference between the beams is pi by 2 at a point A and pi at point B. Alright. Then the difference between resultant intensity at A and B is what? So here you have to find out the what? Resultant intensity. Phase difference between resultant intensity. Okay. So which one is correct? A, B, C or D? Please solve. Okay, this one is correct, but you need to find out the uh, correct solution. Okay, please solve. Similarly, we have more questions. Question 4. Okay, then question 5, then 6, 7, 8, 9 and 10. Okay, these questions helps you to boost your help to boost your preparation. Okay, or work as a booster. So any doubt in these questions? If yes, please ask. Anyone? Yes or no? Varsha, Karthik, VK. Any doubt? Which one? This question, sixth question. All right. Let's see. Here, using Huygens principle, which relation is incorrect for the refraction of a plane wave at interference of two media? Listen carefully. Here you have to find out the incorrect. Okay, incorrect. So all the options looks like a Snell's law. So we know the Snell's law. Snell's law. What is that? Good. So Snell's law, it is sin I upon sin R is equal to n2 upon n1. Yes or no? And we know, okay, v1 v1 is equal to what? Cn1. Okay. And v2 Cn2. Okay. Then what? Okay. So using these two equations, we can write sin I upon sin R equal to v1 upon v2. Okay. All right. Let's see the solution. So v1 upon v2. All right. Okay. So incorrect is which one? This d1. Sin I upon sin R is equal to n1 upon n2. All right. Okay. Clear? So that's all for the today. Thank you for your attention, everyone. And please solve all these questions. All questions work as a booster. Okay. And if you have any doubt, please come on doubt session. Okay. Very good. Very good. Thank you for your attention. Thank you. Thank you.